All right, so the learning targets. For this lesson are that you can graph. Today our focus is going to be on tangent and a little bit on cotangent, but mostly tangent. But cotangent and tangent work the same way. They just, they're like, yeah, it's like a reflection over the x-axis. So can you graph tangent and cotangent? And then the next lesson we'll do reciprocal functions for sine and cosine, which are cosecant and secant. Can you find the period, frequency, phase shift, which most of that stuff's the same except the period's a little different. The period for tangent is not the same as the period for sine and cosine. It's a little different. And can you write a trig function given amplitude? You kind of did that on yesterday's homework. So if you know how to do those things, you'll have an opportunity to try some of those, and we'll solidify that at the next lesson as well. So the tangent function, first off, if you look at your unit circle, which I should probably have pulled one up on the screen. We're going to pull it up on the screen right now. Maybe. Maybe not. All right. No, you won't have electronic devices on your next quiz or calculator, but so here's a pretty unit circle, we hope. Oh man, that's hard to read. Is that better? That's horrible. That's okay. I can deal with that. All right. So if you start here, what's the value of tangent here? 0, right? Can I just use the quadrantal angles? Will that work for tangent? Nope. Works for sine and cosine. Doesn't work for tangent, as you saw with your exploration. So I have 0 here. What is the value of tangent up here? Undefined. Are there any values between that I should find? Pi over 4, 45 degrees, yes. Square root of 2 over square root of 2 over 2 over itself is 1. So we need those, we need every pi over 4 units or every 45 degree increments as we go around. Also, if you remember the graph, okay, why is it there, of this, the graph looked something, let me get a scrap piece of paper, like this when we did it in our exploration. How many periods do you think we actually graphed there when we graphed tangent in our exploration? 1 full period, and then we actually have 1 full period right here, and then part of 1 here and part of 1, so kind of 2, but not exactly 2. And that's when we went from 0 to 2 pi in your exploration. So where do you think I should actually start for the first period of tangent? Where does it start? It starts at, it has these asymptotes, right? Where do those occur again? Pi over 2, right? And where else did they on the unit circle? 3 pi over 2. And then if I want to have a negative unit of this, I could actually go back. By the way, how far apart is pi over 2 and 3 pi over 2? More than that. Why isn't it popping up? Pi degree, pi radians. Did I say, yeah. 180 degrees are pi radians. Pi over 2 to 3 pi over 2. I could also go backwards, right? Go back pi units to negative pi over 2 if I want to get that other one that's off to the left, which you can't see because I don't have the screen up there. All right. So if I want to get this, now that would give me 2 full periods. So we're going to make our parent function. We'll just do the positive one for now as we make our parent function for what it looks like. And remember, when you go to do this, using the unit circle, you have to do y over x. If I'm going to do cotangent, what do I need to do? X over y. So starting with our x's at pi over 2, I'm actually going to start at negative pi over 2. Negative pi over 2, and making my way to positive pi over 2, so that's negative pi over 4, 0, pi over 4, and pi over 2. Those are my x's. So what I've done on the unit circle is I've said, hey, I'm going to let the first period come up to pi over 2, but start at negative pi over 2. So start at a backwards angle. And so then my y values, which are tangent of x, this is for the parent function. For negative pi over 2, it was 0 over 1. No, it wasn't. For negative pi over 2 down here, it was undefined. For negative pi over 4, it would be negative 1. For 0, it would be 0. For pi over 4, it'll be positive 1 using our unit circle. And for pi over 2, it'll be undefined again. So that will complete one period. And if I wanted to get a second period on there, I would go all the way up to 3 pi over 2. We'll do that when we go to graph the other functions. So I'm going to make this negative pi and this pi. Here's pi over 2. I probably could have scaled it even differently. So that's going to be your negative pi over 4 and your pi over 4. And I start with my asymptotes. I always graph those first, because that defines the period for tangent. And then I put the points for negative pi. It's going to be negative pi over 4 will be negative 1, 0, 0, and then pi over 4 is 1. And so the curve of the graph, oh my gosh, 2 blue pens. As it goes down, it approaches the asymptote on the left, and as it goes up, it approaches the asymptote on the right. Thank you. There's a copy of the notes right up there. Any questions on graphing one period of tangent? Now, how long is its period, anyhow? Pi radians, right? So the period for tangent, for sine and cosine, it was 2 pi over b. For this, it's going to be pi over b. And it'll be the same thing for its reciprocal function for cotangent. Pi over b is how we find the period. Right now, our asymptote's at pi over 2. And it's pi units away from this one, right? So guess how many units it's going to be away from 3 pi over 2? Pi units. Every pi units from this asymptote, we will have another vertical asymptote. So our vertical asymptotes can be found by one we currently know, plus the period times n, where n is an element of the integers. So if you multiply that by 2, then it's going to be or by 1, it'll be 3 pi over 2. By 2, it'll be 5 pi over 2. By negative 1, it'll be negative pi over 2. So you'll get all your asymptotes that you could ever possibly graph, not that you want to graph them all, from that. Now it'll change a little bit when we have a value for b, but it still will be dependent on the period. So it's 1 we know plus the period times n. For this, we're going to have to, by the way, will this have an amplitude? Does tangent even have amplitude? No. It could have a vertical stretch or a vertical compression, but it's not going to be called amplitude because it's not sinusoidal like sine and cosine. All right, locate the vertical asymptotes, state the period, and sketch the 2 periods of each function. So luckily in this thing, we only have one thing. There's no vertical stretch or compression, no vertical shift up or down. And I don't have a plus or minus inside, so I don't even have a phase shift yet. We will soon. So what does that 4 represent anyhow? It's b. b is 4. But what does that represent in terms of our graph? A horizontal compression of 1/4. So even though they don't ask for that, it's good to keep that in mind because that's what we're going to have to do to x. Locating the vertical asymptotes, we'll do that at the end. We have to do kind of like we did up here, state where all of them will be. So we'll do that at the end once we actually know what our first one is. It's going to shift. It's not going to be pi over 2 anymore since we have a value for b. Stating the period is easy because that is pi over b, so the period is going to be pi over 4. And then sketching 2 periods of the function. So I'm going to make a table. And last time I had them just do 1 period and then we expanded it to go further. But some people got confused and had a hard time scaling the graph then. So my recommendation would be, when you do this, go from negative, if you were asked to do 2 periods, go from negative pi over 2 all the way up to 3 pi over 2. That'll give you 2 full periods of tangent. So negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. There's our first period of tangent. Using the unit circle, the next value is 3 pi over 4, or 3/4 pi, and then pi, and then 5/4 pi, and then 3 pi over 2. So my list got a little longer than I wanted it to. That's okay. And then we know, by the way, for sine and cosine, if you did all of those graphs, you should know, hey, what are the values that go next to each of these for sine and cosine? You might not know it right away, but you're going to see this repeatedly for the parent function. That at negative pi over 2, it's an undefined value, and then negative 1, 0, 1, and then back to undefined. And this pattern repeats through all periods of the parent function. So the next one is negative 1, 0, 1, undefined. So every time you go to graph tangent, if you start with this as the parent function, you'll know these values. So now all I have to do, I'm still going to graph those y's. Those will be the final y value. That didn't change. But I need my new y value, my new x, and I'm going to write that over here just because I want to use the same table when I get down to letter B. So my new x, maybe I'll do it this way, my new x and y. Instead of negative pi over 2, when I multiply by 1/4, it becomes negative pi over 8. When I multiply this, by the way, to get my new x, I have to do 1/4 times my old x. So this will become negative pi over 16, 0, pi over 16, pi over 8, 3 pi over 16, pi over 4, 5 pi over 16, and 3 pi over 8. Now the cool thing about this, even though I have them in different denominators, even though they're in different denominators for different units, I could convert them all to 16ths if I want so I can see how they're evenly spaced. But I know that my parent function, these were already 45 degrees apart. So now, instead of being 45 degrees apart, they're each 22.5 degrees apart. So they're still evenly spaced. So when I go to graph this, I just have to know what my max number is and my minimum number for the x's. And the y values didn't change, so it'll still be undefined, negative 1, 0, 1, undefined, negative 1, 0, 1, undefined for my 2 periods. The very first thing that I do is graph the asymptotes, but I also want to know, what's my max so I can scale the x-axis. So the highest I have to go is 3 pi over 8, which is just under pi over 2. I do have 0 on here, so I could scale it by 8ths or 16ths if I wanted. I could actually I probably would do this, that this is pi over 4, and that makes this pi over 2. This would be negative pi over 4 and negative pi over 2. Pi over 8 is half of this, so there's my negative pi over 8 for my first value. That's my vertical asymptote. And then the same thing, this pi over 8 would be halfway between pi over 4 and 0. 3 pi over 8 is going to be halfway between these two. So there's my asymptotes. And now I need half of that is negative 16, so that'll be there. There's 0. There's positive pi over 16, 2 pi, 3 pi over 16, 4, 5 pi over 16. So I just have these evenly spaced now between them. 1, 2, 3, 4, 1, 2, 3, 4. So at this one, I go to negative 1. At 0, it's 0. At pi over 16, it's 1. At 3 pi over 16, it's negative 1. Pi over 4, it's 0. 5 pi over 16, it's 1 again. So just like our parent function, this will look the same within those asymptotes, this one going down, this one going up. Two things could make it go the other way. What's one of them? A reflection. Yep, a reflection could do that. Make the graph look different either over the x or over the y. The other thing that would make it look different is if it was cotangent. And I'd have different places for my asymptotes then, but it would be the flip of this. Now the one thing we were asked was to find the period, or not the period, we already have that, to find the vertical asymptotes. Well, on our graph, we already determined that our first positive one is at pi over 8. So we can say that the vertical asymptotes will be located at pi over 8 units plus, what should I add to it to get the next one? Pi over 4, the period. Pi over 4n, where n is an element of the integers. So there's how we get our vertical asymptotes. We find the first one, we add the period to it. Find the first one, add the period to it, find the first one, subtract the period from it, puts us right there. All right, letter B. Any questions on the first one? Letter B, finding the tangent of x over 2. Well, we're going to start with the same parent function, so I'm going to zoom out so I can actually do that on this table. If you want, you can recopy the table. This is just one operation, so I'm not going to worry about that. So this is x over 2, which means that b is 1/2, which means what we're going to do to x is do 2 times our x variable because it's a horizontal stretch of 2. What's the period going to be? Pi over 2 or 2 pi? 2 pi, because it's pi over b, and pi over 1/2 we multiply by the reciprocal, and we just said it was a horizontal stretch. So if the original period of this thing is pi, and now I'm adding, now I have a horizontal stretch of 2, we expect it to be 2 pi. So that's our period, and that'll help us when we go to find the vertical asymptotes too. Got to find the first one, and then we're going to add to it 2 pi n, where n is an element of the integers. We just have to go back and fill out that part. All right, so now I'm just going to multiply all my x's by, and I'll do that up here probably to save myself time. So this is letter B, by 2. So this is negative pi. This becomes negative pi over 2, 0, pi over 2. Whatever I have up here, I'm going to have down here when I multiplied. So that'll be pi over 2. That'll be pi. This will be 3 pi over 2. That'll be 2 pi. 5 pi over 2. And 3 pi. So now, the tricky part with this is my x-coordinates are here on the left, and my y-coordinates are here on the right. The highest that I have to go to, and I want to first plot my asymptotes anyhow, the highest I have to go to is 3 pi, the lowest I have to go to is negative pi. So I'm actually going to just take my graph and extend it a little bit to make 3 pi out here. And this will be 2 pi and 1 pi, negative 2 pi. I'll put my vertical asymptotes at negative pi and 3 pi. And then I'm just going to plot the values from there. At negative pi over 2, we have negative 1. At 0, we still have 0. At pi over 2, we have 1, because there was no vertical change from our parent function. At 3 pi over 2, we have negative 1. At 2 pi, we have 0. And at 5 pi over 2, we have 1. So there's what our tangent graph looks like for this one. The vertical asymptotes, the first one's located at pi units. Pi plus 2 pi is 3 pi, so we know that the formula we've written works. Any questions on example 1b? All right, when you're ready, flip the page over. Now we have this with other transformations, including vertical stretches, vertical compressions, phase shift. So now that we kind of have a general understanding of how to graph tangent, the parent function, and change the period, we're going to look at doing all transformations with it. So again, we're asked to locate the vertical asymptotes, state the period, state the phase shift, state the vertical shift, and sketch 2 periods. So we're going to make another table going for 2 full periods. Some of you like to do this. If you do this, you're going to find your period by doing the opposite of pi over 6 divided by b. In this case, b is 1/3. I choose to factor it, to rewrite it. You don't have to do it that way. I would rewrite this as -2 tangent of 1/3, and then in parentheses, x plus. Okay, so if I divide pi over 6 by 1/3, I'm actually multiplying it by 3, which is going to make it pi over 2. So I do it like we did transformations in Algebra 2. And doing that, I can see that there's going to be a reflection across the x-axis, so it's going to look more like cotangent. It's going to be vertically stretched, so instead of having 0 and -1 and +1, it's going to be 0 and, well, until we have this shift down, it would have been 0 and 2 and -2, but all that will shift down. I see the 1/3 telling me that b is 1/3, which means it's going to be a horizontal stretch of 3, meaning my period, which was pi over 1/3, is actually pi times 3 over 1. So the period is going to be 3 pi. The phase shift, if you choose not to leave it in this form and do the formula, then you're going to do the opposite of what we see here. So the phase shift is left pi over 2 units. That's why I have negative pi over 2 written. And the vertical shift is going to be down 1. I'll put the vertical asymptotes up there last once we find the original point. Just want to make sure to come back and do that, so I'm going to circle that part to remind myself to do it. Now, based on these operations, what's going to happen to get our new y-coordinate? What's going to happen with the -2? So that's what's going to happen to our graph, but what are we going to do to the y-coordinate? Multiply it by -2 and subtract 1. So I like to make a note for myself that my new y-coordinate should be -2 times y minus 1. Whereas my new x-coordinate, this 1/3 is actually going to be multiplied by the reciprocal, 3, and then I'm going to subtract pi over 2. What the heck? Why was the camera disconnected? It should not have been disconnected. Oh. Give me 1 second. Of course it doesn't. That's not the camera I want. Hi. We're going to pause this for a second. All right, so with 2b, if you factor out the 2, this gives you x minus pi over 2. So you can immediately see, if you just do pi over b, that our period for this function is pi over 2. So it's half of what it was before. That our phase shift is right pi over 2 units. That there's going to be a vertical shift of up 1. And it's not really an amplitude, but we'll have a vertical compression of 1/3. So it'll be a very small graph in terms of how close the points are together. So we're going to start with our table. I'm going to do my table right here for this function. I'll back up a little bit. For negative pi over 2, I'm actually going to do my changes to x here. And my changes to x, since that's a 2, I'm going to have to multiply it by 1/2. And then I'm going to have to add pi over 2 to it. If I can get them all to have the same denominator, that will help. My changes for y, which I'll do over here, So here's my original y coordinates, undefined, -1, 0, 1, undefined, -1, 0, 1, undefined. Continued with the table. So for my y's, since it is 1/3 for the lead coefficient and +1, I'm going to do 1/3 of the y plus 1. So there's how I'm going to get my new x's and my new y's, and I'm going to do that now before we graph. So half of x makes this -π/4, makes this -π/8, 0. The next two are going to be just the opposite signs of the previous two. This will be 3π/8, π/2, 5π/8, and 3π/4. Now, if you're good at scaling your axis, because you know these are evenly spaced, you can do that using these numbers. But to make it quicker for me to add the π/2, I'm actually going to make them all 8s. So this is really -2π/8. That stays -π/8. This stays π/8. This is 2π/8. That stays, this becomes 4π/8. That stays 5π/8, and this becomes 6π/8. Any questions on where those came from? All right, to that we have to add π/2, but right now it's in terms of 8ths. So really, I'm going to be, if I multiply that by 4 to get 8 in the denominator, I'm going to be adding 4π/8. So I'm just going to add 4 to each numerator and keep my denominator. So this becomes 2π/8, which is π/4 if you want. I'm going to leave it in terms of 8ths for making it easier to graph. This one will be 3π/8. This will be 4π/8. Wow, wonder what the next one's going to be. 5π/8, 6π/8, 7π/8, 9π/8, 10π/8. Nope, I did something wrong. I skipped 8π/8. I knew when I got to the last one it wasn't adding. 10π/8. So now that'll be easy in terms of spacing them evenly on the axis, and I'll just split everything into 8ths. For my y-intercept, or for my y values, though, I have to multiply them by 1/3 and add 1. This will stay undefined. This will be -1/3 plus 1 is going to be +2/3. This will be 0 plus 1. This will be 1 plus 1/3, which is 1 1/3. This will remain undefined, and then it's going to repeat these values just like it repeated the values in the original parent function, so I can just copy them down. 2/3, 1, 1 1/3, undefined. So now that I have my table, I can split my axis up. The ones that I want to use what was the equation? For the y, I did 1/3 times the y plus 1. I muted it, don't worry. All right. So we go all the way up to 10/8. So there's my x's from 2/8 to 10/8. And there's my y's that correspond. I'm going to circle them. I was going to highlight them, but I'll just circle them. So we know we have to go to 10/8. I'm going to make this 8/8, 8π/8, which means this is going to be 4π/8. And that'll be 2 and 1 and 3. So 1, 2, 3, 4, 6 and 7 and 8. And I'll need a 9 and a 10 in there because I need that one to be 10π/8. First thing I put in is my vertical asymptotes, which are going to be at 2π/8 and at 6π/8 and at 10π/8. So that defines our first two periods. And then using the table, I'm just going to go through and plot the other points. At 3π/8, I have 2/3, which is 1/3 of the way to 1. I'd probably have rescaled this. If it weren't already given with numbers, I would rescale it. And then the 1 at 4π/8. and then the 1 1/3 at the next one, 6 pi over 8. Same thing over here at 7 pi over 8, 2/3, 8 pi over 8, 1, 9 pi over 8, 1 1/3. It's a little hard to see because it's so closely scaled. So that one's going to approach that asymptote, and then it's going to come up and approach this one down to approach that asymptote, this one up to approach this one. Any questions on example 2b? It does make it a lot easier to graph if you put them all in the same denominator. It's easier to space it out. In the other video, I'll post both that I did third hour, we left them as different denominators, and it was a mess for graphing, even though they were supposed to be evenly spaced. All right. Cotangent function. Kind of like tangent, right? But we have that wonderful unit circle. Oh, thank you. I always forget that. The vertical asymptote. The first one happened at 6 pi over 8, right? Is that right or no? No, it was 6 pi over 8. So that's 3 pi over 4. Plus the period, which we said the period was pi over 2, times n, where n is an element of the integers. So there's our expressions for the vertical asymptotes. Cotangent, I just want to point out to you, remember how do I find cotangent using the unit circle? X divided by y instead of y divided by x. So if you look at your unit circle right here, x divided by y, 0 is undefined. So do I need to start at pi over 2? Nope. I'm going to start at 0, and I'm going to go all the way till I get my next one, x over y, which is at pi. That's going to be undefined also. So instead of starting at pi over 2, it's going to start from 0 radians and go to pi radians. So I'll make a table so you can see what the first one would look like, and then you can go in a negative direction if you want to do the negative ones, if you're looking for two of them. So we have 0, pi over 4, pi over 2, 3 pi over, oh, it's not on the screen, thank you. So we have, so it goes from 0 to pi radians. That's because, again, the period, as we saw when we did our exploration, is pi. It's pi over b for tangent and for cotangent. 0, pi over 4, pi over 2, 3 pi over 4, pi. Except cotangent, yeah, and then it would be undefined, 1, 0, negative 1, undefined. Is that the same as tangent? What's different as I go from left to right? It's positive 1 first and then negative 1, where for tangent it's negative 1 first and then positive 1, because we started, for tangent, we started in, of course it's not showing. Because in this one we started down here at negative pi over 2. And so that's why the first one for tangent is negative. Since we're starting here, the first one for cotangent is positive. That should help you if you go to graph any that involve cotangent. You're going to start with this table, and then you can go negative pi over 4, negative pi over 2, all the way back to negative pi if you need a negative 1. So that's it for example 2b. Any questions?